I'm Thiemann, and I made a hockey blade.
The hockey stick is the most important piece of equipment for a hockey player because it allows the player to control the puck. While the current composite one-piece sticks are light and offer great performance benefits, they are not durable enough to withstand the rigors of the game and are very expensive. The current composite sticks are also made using a manual and iterative process that takes a long time. The combination of the manual process, the high price, and the lack of durability suggested the design and manufacturing of these sticks could be changed. My design was oriented on using a two-piece stick design, which separates the blade and the shaft. This allowed me to use a pre-existing stock shaft and focus on redesigning the blade. I developed a CAD model of a new blade design that allowed different materials and processes to be used in an attempt to make the stick more durable and more affordable. The design was also centered on maintaining the low weight and good performance benefits of the current models. This new blade design had the same base design as the current model, but holes were added to keep the weight low. The main change from the current stick was to manufacture the blade with a plastic molding process. This helps reduce the manufacturing time and the material cost. I decided to 3D print the newly designed blade in order to obtain more detailed geometries for the silicone to mold around. The part had to be split into 4 pieces to fit in the 3D printer. One of the parts failed, which meant I had to add supports to stabilize the rest of the parts. Once the parts were finished, they required additional trimming and joining operations to make the full blade model. The holes present a challenge, removing the model from the mold. To address this, I designed the back face of the blade to have sharp perpendicular angles at the holes. This allowed the hole features in the mold to easily be cut along the back face. To test this issue, I decided to use the failed 3D printed part as a small-scale test run. Though the trial process wasn't perfect, it did show that the hole features in the mold were easy to cut. I also wanted to test how the resin worked in this small scale, but the resin leaked out of the mold. Box design was also a large issue with the manufacturing because it dictated how much silicone was needed to create the mold. Not wanting to spend too much money on the mold material, I had to shape the box around the blade. I was able to reduce the total volume of the box so that only 4 pounds of mold material was needed. The box was made out of wood, and the walls were cut using various woodworking tools and techniques. I decided to screw the end of the insert into one of the walls to make this the pouring point for the resin. Due to the complex shape, I decided to tape the box heavily to prevent leaks. The box generated, it was time to create the silicone mold for the blade. I thought using 2 full bottles of the material would be enough to cover the mold, but it wasn't, so I had to quickly make a little bit more material mix to fill the mold. Despite this mistake, the mold came out pretty well and the hole features were easy to cut to release the blade. The next step was to cast the resin in the mold. Like the silicone mix, I did not mix enough resin to fill the mold, so I had to mix additional material to fill it. This was a bigger issue with the resin, because when the blade was released from the mold, it turned out to be very flexible and more transparent than the expected material. Over time, the material hardened and settled into the natural form. I decided to cast another blade to see if I could produce a better product. This go around, I used a scale to improve my accuracy and gave the resin more time in the mold. Though it still needs some finishing once it was released from the mold, the blade seemed to be a more accurate cast and a better product was produced. The final step was testing the blade. When testing the blades, the second casted blade broke at the insert on the first shot attempt. I had to tape the blade to the stick to test the rest of the blade in some way. Despite the insert failure, the overall stick felt light and handled the ball well during the tests. After several shots, the tape finally gave out, but the blade itself held up to the stresses. I also tested the first casted blade and added a layer tape of support at the insert. The stick was a similar weight, but it didn't handle as well as the other casted blade. This first casted blade also broke after much less shots at both the insert and at the toe of the blade. Overall, I felt this prototyping process was somewhat successful in developing a new hockey blade despite the failures. If this project continued, the blade would need updates at the insert, and a more applicable material would need to be selected to make the concept feasible. Thanks for watching. I hope you enjoyed my project.